So, but sound is omitted, no?
Yes,
From the second term's portion, then why are we doing sound chapter?
that was remaining. That's why. So that is omitted. Correct way. So is there any chapter remaining other than sound? Yes. Yes.
No,
Okay, just name it. First chapter was what?
sir, your
But
voice
your
is not
voice is
clear.
So,
yes,
again,
sir.
your voice started.
I'll do. Just name it. Do this activity. Please speak name of the chapter. Do this fast. Okay, in your next semester, which all chapter is going to come in the final? First chapter is semester is over, correct? Correct?
Yes, sir.
So now what going to come in the, tell me? Yes? Yes? Do it fast so that I can do something. Still voice is not clear?
It's
Sir,
clear.
it's clear.
It's clear?
Yes.
Okay, thank you. Now tell me, just name of the chapter is going to come in this semester. One after another, fast.
So, I'm not sure, but I think motion, force and laws of motion, gravitation, work, and energy.
Correct.
Yeah, sir. Only these four. And sound is omitted, right?
Correct. Okay. And sound is omitted. Okay.
Sir, but even if we do, there's no loss in it.
Even we do what?
सर अगर हम लोग करते हैं तो भी हम लोगों को कोई लॉस तो नहीं है ना, मतलब
Correct.
समझ नहीं
Correct.
मिलता.
Correct. Correct. ठीक है, तो मैं इसको समझने की जैसा बता देता हूँ. ठीक है, नॉट गोइंग मच डिटेल. ठीक है, एक साउंड
Okay,
Sir,
चैप्टर
sir.
we
क्या होता है?
have time of detail.
यस.
सर हम लोगों के पास बहुत टाइम बचा है अभी सेकंड टर्म के लिए, तो आप करा सकते हो. ठीक
ठीक है, मैं साउंड चैप्टर करा देता हूँ, जस्ट फॉर अंडरस्टैंडिंग. ओके, डिफरेंट
Yes.
टर्म्स एंड नेम एंड इट्स यूज. ओके, तो कुछ पॉइंट्स में इंपॉर्टेंट बताऊंगा. लास्ट टाइम जो इंपॉर्टेंट पॉइंट थे उसको समराइज करो. यस. हाँ हाँ, मैं देता हूँ उसको. बोलो व्हाट्सएप नंबर, कुछ नंबर, ये फोन दो. नहीं तो आप ही दे दो, मैं आपको नंबर पे ट्रांसफर कर देता हूँ. ठीक ठीक. I'll teach you only 3 topic in the sound. Okay. Audible? Clear? Yes?
Yes, sir, clear.
Okay. So I'll teach you only 3 concept in this chapter, which is useful for you. First, I'll teach you resonance, echo, and factor affecting the sound. Okay, factor which can affect the sound, right? So which all factor can affect? So let us discuss one by one. Do we find any difference in summer and winter? Yes. Do we find or no? Yes, we
Yes.
find. Right? In the winter season, in the morning, we see hear the voice from very long distance. Even sometime we nearby the station, we hear the train voice, right? Do we hear it in the daytime? No. So in this, we see longer sound, distant sound, right?
Yes.
So that weather condition will affect. Can temperature also affect? Yes,
Yes, sir.
surely. Now, humidity, can it affect? Humidity of the medium?
Yes, sir.
Okay. Now, which are all other possibility which can affect? Yes. हाँ ठीक
So, medium.
हाँ हाँ भेजिए ठीक ठीक है 514 भेजिए 540 ना 530 ठीक है सर The fourth option will be pressure, right? How pressure can change sound? Can anybody give an example, simple example? Yes. Yes.
Sir, when you're coming down from an aeroplane, like when you're landing,
Yes. That is also correct.
Sir,
Yes.
sir, with pressure,
Yes. 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 Tell me. With pressure.
sir, can you hear me?
Yes, I can hear you.
Yes, sir. Sir, if you increase pressure, then the molecules come more closer together, and therefore speed of sound increases. And if you decrease pressure, then molecules move far apart from each other, and therefore speed of sound decreases.
Correct. Correct. So all of you understood? Because of the pressure, density will vary. What will vary? Yes.
आपकी स्क्रीन ब्लैक हो गई
Okay, I'm just doing some setting here. Oh no. Wait a minute. So that explanation was correct, right? Is it coming black, this whiteboard?
Yes,
Yes,
sir.
sir.
Sir, what is the color on your screen?
Black only, just checking. Okay.
Sir, I have.
Yes.
Then what is can you explain Newton's formula of sound?
Yes. Yes. So Newton, just I'll again share the check. Just like the light, Newton also gave some formula in the sound. He calculated the speed of the sound. What? What? Speed of the sound.
Speed of sound.
Correct? But he made some mistake taking the assumptions. And he come out the speed of the sound something about 280 meter per second. But experimentally calculated values was far different. What is experimentally calculated value? Yes?
340 meter per second.
340. So what was the mistake he did? That is a point to understand. Okay. Okay.
Sir, in that formula, there is elastic coefficient of medium, right?
Coefficient of, yes, medium. Coefficient of,
Yes, sir. So what does that mean?
no, the another scientist comes and he gives that formula, coefficient of elasticity, right? Rigid medium. That formula was given by another scientist, then come it's true. Before that, Newton didn't taken this as a medium of elasticity. Getting?
Yes, sir. Sir, maybe
Sir.
you can share your screen and but draw on a different app or something.
Just a
Sir.
minute, I'm just taking how if black is coming.
Sir, I have a doubt. Can I ask? Hello, sir.
Okay, do one thing. Take a break for 2 minutes, 3 minutes, something like 5 minutes. I'm just sorting out this. Okay.
Jitendra, so can you hear me?
Yes, yes,
So I have a doubt.
yes.
Can you explain me Mach numbers and resonance?
Resonance and
Mach numbers.
Mach numbers.
Yes, sir.
Yes, I'll explain the resonance. Just I'm setting this screen. Just wait a minute. Okay, can you hear me? Yes.
Yes, sir.
Okay, right now
Yes,
not
sir.
able to fix up. I'll change the device only. Just answering the question resonance. Okay. Yes, you are there.
Yes,
Okay. So resonance means what? There is a natural frequency and there is a frequency from outer source. Okay. For example, these two are the frequency are there, right? It has its own frequency and it has another frequency, right?
yes,
When they will come together, both have their own frequency, right? And when they match each other, right? When they have frequency in such a way that they superimpose each other. Superimpose means what? The wave you have seen, the crest and trough, like this. Yes, one part is
yes,
upper and another is lower. So when upper comes on the
yes,
upper, the resultant comes in the form of vector. So this point A and A both added together become 2A. So this amplitude become 2A. Are you getting? Are you getting?
So
And
can
when,
you explain?
sorry, I, do you face this the black screen in any other class? I am facing first time. Yes.
No, sir.
सर आपको खाली प्रेजेंट करते वक्त ही हो रहा है ना?
No, other time also. Whatever writing is getting emitted fast.
So you can use some other app to draw.
Oh, thank you, thank you, thank you. That I will use another screen only. Okay. Do you know any board, digital board?
Sir, there is Google Jamboard.
Yes.
Okay. Okay. Okay, thank you. This is nice. Okay, now can you see?
Yes, sir.
Okay, thank you very much. So, resonance, right? So this is a wave, correct? Correct? Now this is another wave. This is right. Now if they arise together at a point, right? So this has vector A, amplitude A, and this has amplitude A, correct?
Yes, sir.
So now what will happen when they will come together? This wave will superimpose on each other at a point in the medium. So they will make a resultant and they follow vector law. So because both are in the same direction, they will be added up. Are you getting?
Yes,
Are
sir.
you getting? So this will become 2a plus and down also 2a minus. So this is called resonance. Resonance means what? When same nature of frequency come together and make maximum. Are you getting? I'll give one more
Yes.
example. I'll give one more example. Just like bottle, right? This is a bottle and I'll fill water to some amount in it, right? Right? And now I'll take a tuning fork, from, I'll keep on it. Okay. Now what will happen? Because suppose this frequency of this tuning fork is 250 hertz, right? And fill the water such a way that a wave will be set up inside. In wave will be set up inside, right? It will have wave inside the bottle is 250 hertz. How much? 250 hertz. So when your outer, right, frequency and the natural frequency of the bottle is same, it will vibrate with the sound, maximum sound. Yes, yes,
Yes.
this column will vibrate with the maximum sound. This is what the graphical representation of this resonance is given by this formula diagram. Do you understand?
Yes, sir. Sir, but in resonance, there's one thing called mechanical resonance. Is it the same or it's different?
Mechanical resonance or any resonance. Resonance means resonance. Only thing I'll explain it. Say for example, can you give any example? You're asking for mechanical. Yes.
No, sir, I don't.
Okay. So there are resonance, like the army cannot march on the bridge. Do you have heard this? Huh? Do you have heard this? Army cannot march on the bridge. Yes. They can do parade everywhere on the road, but as soon as bridge will come, right? Right? They will walk like a simple man. They will not do the military march. Why? Why do you know? Because
No,
this bridge has its own frequency. This is called natural frequency. This is called
natural.
natural frequency. And now because of the dumping the leg of the army altogether, some natural the frequency will be set, and that is called force frequency. That is called.
Force frequency.
So when force frequency and your natural frequency match, then what will happen? This bridge will vibrate with maximum amplitude, with maximum.
Maximum
And if bridge will vibrate, what will happen? It will collapse. It will
collapse.
collapse. I'll give one more example of resonance. Like 100 students are there in the classroom, or 50, correct? Correct.
Yes,
Do we feel connected to everyone? To extent, some extent, everyone, not very much, correct?
yes,
But there is someone A or B, somebody we like resonate with them, and then we develop a friendship, correct?
correct.
So because your thought process and his thought process, her thought process is same, so you resonate there. Similarly, in this characteristic of wave, it has own phase of wavelength, another has same phase, and they resonate. What happens if they have opposite? Suppose in the last example here, if the wave is coming and it has some opposite, suppose this one, like this, can you see dotted line?
Yes,
So now here vector upward and here vector is downward, so they will cancel each other. So that wave will be like this, something, there is nothing, zero amplitude. Are you getting?
yes, I understand.
Okay, and what was the next question? Resonance, another.
Mach number.
Huh?
Mach numbers.
Mach number, MSc.
Yes.
Okay, match number, not it is Mach number, it is match number.
No, sir, it's Mach number.
M
MSc.
MSCH na?
Yes.
It is okay, match number, Mach number, okay. So ये सबको समझ में आया? जो आज हम 3 टॉपिक कवर करने वाले से, उसमें से एक रेजोनेंस भी था। समझा सबको? हाँ,
Yes.
ओके। अभी एक और इसका एग्जांपल आता है आपके सिलेबस से कि सपोज एक बॉक्स है।
Sir, your voice isn't clear.
Sir, I have a doubt.
Yes, 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 yes,
Sir,
ask
your
it.
voice This is cracking.
I don't know. Network is showing weak, or is it something? Is there something on my network?
Sir, maybe your mic issue.
Yeah,
Yes, sir, it's your mic issue only.
Okay. Okay. Just a minute. I'll change the mic only. Okay, ask your question.
Yes, sir. Sir,
Yes.
sir, is wavelength scalar or vector?
Good question. So always remember the fundamental. Who would like to answer? This is yes.
your
Not audible. Huh? Not audible. Correct.
Sir, it's audible, but it's cracking a lot. We can't understand.
Okay. Still cracking.
Yes, sir.
Still cracking.
a little bit.
Okay.
Sir, it's almost gone.
Gone means sound.
Yes, sir. Now it's not cracking.
Okay. Thank you. So I am saying wavelength, right? Right.
Yes,
So
sir.
is it a scalar or vector?
Yes, sir.
So
Sir,
see
and
this
even
is
amplitude.
okay. See this is a length, correct? Correct.
Yes, sir.
And wavelength we measure from initial to final point, correct?
Yes, sir.
And wave velocity we find displacement upon time, distance upon time, correct?
Yes,
And
sir.
now this is amplitude, right? So we write it
Sir.
plus a and minus a, correct?
Yes, sir.
When we write plus a and minus a, when we consider the direction, right? So
Yes, sir.
amplitude
But work also has plus and minus, but it is not a vector.
work is based on the angle, correct?
Yes, sir.
And here it is based on the direction. So direction of
Sir, the wave.
vibration of the particle. So that's why it undergo vector addition. Just I explain na resonance. What happened there? If it is not a vector, then will there be a vector addition?
No,
Tell
sir.
me. So amplitude is a vector, understood?
Yes, sir. Sir, and wavelength.
Okay. Now question for you about wavelength. Yes.
Yes, sir.
What should be the wavelength? It is a vector or yes?
Sir, I think it should be a scalar.
Because we calculate the speed of the wave, correct?
Yes, sir.
That means what? It is a scalar quantity because time is not is always a scalar.
Okay,
Correct.
sir.
So this is a
Yes, sir.
scalar quantity. Understood?
Yes, sir.
Okay, next question. Yes, please. Match number, correct?
Yes.
So basically it deal with what? It deal with the speed of the object and speed of the sound. Speed of
The
object.
object and the speed of the sound.
Yes. So basically it will deal with what? If object is traveling with the higher speed than the sound, then its match number will be greater than 1. If its speed is less than sound, then it will be less than 1.
One.
If equal to, then it will be 1. Are you getting? So this is we use in the sonic, supersonic, like this name, sonic, supersonic.
Subsonic.
Right? Sonic word itself is saying something about the sound, correct? And
Yes.
there is also word subsonic.
Yes.
What the name itself is suggesting, subsonic means match number is less than 1, right? Supersonic saying equal to 1, supersonic saying greater than 1, correct?
Yes.
Yeah. So this is what, comparing the speed of the object with the sound, we get the match number. And match number gives the idea whether it is a sonic, supersonic or subsonic. Any more question in this?
No, sir. Sir, can you give a question on that?
Yes, I can give. Aircraft is there, right?
Just a second, sir. Writing this.
Yes, please write it fast.
Sir, what is elastic coefficient of a medium?
I'll tell you. Coefficient of elasticity of medium. So there is two kind of medium. One is elastic, another is a plastic. Getting? Hmm?
So what did you say? Elastic and?
Plastic.
Okay, sir.
So elastic means one, after removing the applied force, the object comes back to the normal position. Whereas plastic, once you applied the force, it will not come back to the original position. Getting?
Yes,
Yes.
sir.
So coefficient of elasticity is the stress upon strain at the point. The stress is a force per unit area and strain is change in length upon original length. Are you getting?
Sir, can you write it?
Yes, wait a minute. Is it completed, match number?
Yes.
Okay, I'm giving a question on it. Then we'll move to the next topic. So, okay. Tell me. Okay, question I'm giving. Speed of sound and latitude of 10 kilometer. Speed of sound is there. At latitude matlab ऊंचाई, right? How much? 10 kilometer. How much is the speed? 1060 kilometer per hour. Correct?
Yes.
What is the Mach number of the aircraft flying at a latitude of 10 kilometer when the speed of?
1000.
Yes. So this aircraft now speed is how much? Now speed is how much?
Sir,
One 1800, right?
it would
Then
be
what
1800 upon
what will be
1060.
Mach number? So speed of sound at 10 kilometer height is this much. At the same height, right? Speed of object is how much? 1800. What will be match number?
1800 upon 1060, which is equals to 1.7.
So it is a speed of object upon a speed of sound, not opposite. Getting? So it will be not that, but 1800 1060. नहीं समझा?
Sir, समझा?
Okay, good. So this type of example they can ask. समझा?
Yes.
Okay, now who was asking the next question?
Sir, me, Pratham.
Should I rough it or you are
Yeah,
noting it?
sir.
Please. Okay. So you should note it down. Good question it is.
So I have written.
Yes, Pratham, you ask your question.
Sir, what is elastic coefficient of a medium?
Okay. Coefficient of elasticity it is called. Coefficient of
Elasticity.
elasticity. So suppose I am applying the force on this, right? So it may shift something somewhere. Force upon area is called stress, right? And due to force some change will happen. So that change in the length upon original length is called strain. Okay. Okay.
Sir, can
Then
you
this
repeat strain? What is strain?
change in length upon original length. If you are applying some force, right? Right. So length will change now.
Yes, sir. Yes.
Elongation will happen. So
Yes.
stress is directly proportional to strain. So stress upon strain is constant, right? And that is a coefficient of elasticity. Are you getting?
Yes, sir. Got it.
Okay. So this mistake was made by the Newton, and that's why he didn't got it.
So what have you written at last?
Coefficient of elasticity. That is something like this. This sign.
Okay.
Sir, and what is Young's modulus and Bulk's
Young modulus
modulus?
is this only. That there is different kind of stress and strain. Longitudinal, bulk, aerial, like this. So when there is a longitudinal stress upon longitudinal and strain, that in that case this coefficient of elasticity becomes Young's modulus. When we are talking about the bulk means volume, right? So change in volume of the original volume is also a stress, right?
Yes, sir.
So then what will happen? Yes.
Sir, I can't hear you.
So this is Young's modulus. When the stress is a longitudinal and strain is also longitudinal. So what is longitudinal strain? This is longitudinal. Change in length upon original length. Are you getting?
Yes, sir.
So that constant of elasticity is called Young's modulus constant. When they change in volume upon volume, that is called bulk modulus. Yes.
Yes, sir.
Solved? Solved?
Yes, sir.
Any other question?
Sir, can you tell the difference between echo and equalization?
Echo and?
Equalization.
Okay. So what is echo? First tell me. And what is minimum criteria for this? Yes. Yes.
Yes, sir. The echo is when we speak something and then it gets echoed and we hear it back again and again.
Yes. 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 So what is minimum criteria for this? Hmm?
Sir, sound and an object which can reflect the sound.
Correct. Anything else? Okay. So minimum should be 17 meter back and forth. That is total is 340. Correct?
Yes,
Why? Because in your ears, the difference
sir, your
between
voice.
in your ears, the difference would be at least this much. 1 upon
So
10
still
seconds.
it's cracking. Can't understand.
Now, how it is? Yes? Better?
No, sir, it's still coming.
Mhm. Okay. Then I'll do something.
So now it is okay.
Okay?
Yes, sir.
Okay. Okay. So 1 upon 10 second, that difference should be there in your ears between two sound to hear it distinctly. Correct? Correct? Minimum this time
Yeah,
period is required. So in order to get minimum this time period, how much distance a wave should travel? I want to not hear two wave distinctly. I want to hear one wave distinctly. That means it will go certain distance and come back. Correct? So minimum time period should be 1 upon 10. And what is the speed? 340 meter per second. Correct? Then what should be the minimum distance? Are you getting? So what is formula? What is formula? Velocity is equal to distance upon time. Correct? So time is equal to, sorry, distance is equal to velocity into time. Correct? Distance is equal to velocity into time. So velocity is 340 and this is 1 upon time. So total distance will be 34 meter. And that can be divided into two part. Why? Because 17 for going and 17 coming back. नहीं समझा? Yes or no? सो अगर
understand.
ऐसा कोई आवाज आएगा तो इसको इको कहते हैं और इसी सेम सिस्टम को सोनार भी कहते हैं। आया समझ में?
Yes,
साउंड नेविगेशन एंड रेंजिंग। इकोलेशन किसको कहते हैं? हाँ? जब पानी में जहां जाती है ना तो नीचे तरंग छोड़ती है और फाइंड करती है कि कोई जानवर नीचे है क्या, वे ब्लू वेल है क्या, शार्क है क्या। सो इकोलेशन, ये इको को यूज किया जाता है। किसको यूज किया जाता है? इको को, टू डिटेक्ट द ऑब्जेक्ट। किसके करने के लिए? किसके लिए?
to detect the object.
जैसे ये इकोलेशन है, एक जगह गया यहाँ से वापस लेके आया तो कितना डिस्टेंस है पता चल जाएगा। लेकिन यहाँ पे ब्लू शार्क आ गई है, अब जाएगा वेव, क्या होगा? इसी से टकरा के वापस आएगा। आया? खतरे से पता
Yes,
चल
sir.
जाएगा ना कोई तो खतरा आ गया है। आया समझ में?
Yes,
ओके, एनी अदर क्वेश्चन? हम्म, बोलो, आवाज क्लियर है?
yes,
ओके ठीक है, कोई और क्वेश्चन तो पूछो, नहीं तो आगे बढ़ूंगा मैं।
So what is the formula for equation?
Very simple. When equation will be there, right? Right. So what will happen there?
So is it total distance upon like the total distance traveled upon time taken?
Yes. So equation you cannot see here if the object will not come back, correct? So 2s, that means total distance upon time period, correct?
Yes.
So 2s is equal to what? Velocity into time. So distance is equal to v into t by 2. That we have just derived earlier. पहले हमने इसको फाइंड किया है, देखा आपने?
Yes, sir.
Okay, good. Any other question? Yes.
No, sir.
Okay. Any more question? Hmm? Yes, tell me, any question more? No one?
No, sir.
Okay, good. So in the sound resonance and the factor affecting the sound, we have learned. Echo also we have learned, right? Almost all
Yeah,
the parts
sir,
we have
your
covered.
voice is.
Wait, I'll change the system only.
Sir, now it's clear.
Okay, okay. So now should I rough it?
Yes,
Okay. Should I give any question to solve?
yes,
So the equation, right? One application I told you in the sonar. Can you list out two more application? First, where you can use it. Yes, yes. When some particular design is made, right? Object, suppose some pipe is there, right? Now the wave goes through it, right? And in between path it turns back. That means there is a defect. So finding the defect in the object, we do it, right?
yes.
So similarly, this equation has many more application. So we'll come back to the
So
numerical. Yes,
even bats use equation to find food.
yes, yes, yes. Bats, correct. So they use equation, right? They send the wave and they reflected back, and then they sense that there is some obstacle in the path. They change the path now. Now tell me, who has given this technology to the bats? Huh? Microsoft, Amazon, any company given?
We have that.
Who has given? Somebody must have given, no? Right now, this is a only good brain can ask this question. Einstein used to ask, who has given? I'm doing so much research and this whole life I've given. Then I found out how to transmit, how to receive this and that, and they are chamgadad, are not educated, not gone to any school education. They are doing it freely. How it is possible? Are you
God.
getting? Yes. Yes. Any question from anyone? Huh?
No question.
Okay.
Yes.
So I'll take you further on some question. Okay. Okay. And then you have to solve it. I'll give some formula before that so that you can solve it. So the temperature, the how it affect temperature? Yes.
Sir, can I say?
Yes.
Sir, speed of sound increases by 0.61 meter per second every
Yes.
1 degree Celsius rise in temperature.
Yes. Correct. So density is there, and how it will connect? So velocity is,
Velocity of sound is inversely proportional to square root of density.
yes. Why? The density increases, then
So velocity of sound decreases.
yes. So now this is the effect of density, right? Now how will it affect on the humidity?
So the
How,
density of water vapor is less than dry air at the same temperature.
correct. So speed of the sound increases as humidity increases, and increase in humidity is what? Is relation with again density, right? And what about the temperature? Velocity is directly proportional to square root of temperature.
Yes.
So the degree it will increase, it will also increase the velocity. Yes. So based on this few question, you solve one question I'm giving you. Ready for it?
Yes.
Yes. So temperature is changing from, for every 1 degree Celsius rise in temperature, how the velocity of the sound wave will change?
Sir, I know. Can I say?
Yes.
Sir,
Temperature is changed by
0.61 meter per second.
how much? 0.0
61 meter per second.
0.061. Okay. How? Yes.
Sir, that I don't know. But I know this because my sister knows.
Okay. Velocity is directly proportional to square root of temperature, right? Right.
Yes.
So when there is a change of 1 degree Celsius, then how much will be change in the velocity? If you will find that, we can solve it, correct? So V upon V2 is equal to root of 101 upon 100, correct? So root of 1.01 is equal to V1 upon V2. So V1 is a velocity at what point?
So can you explain this again?
Okay. I'm just considering a case. This is expression I have, correct? Velocity is directly proportional to square root of.
Yes, sir.
Okay.
Temperature.
Now the temperature in this side we take in the Kelvin, so it will be 273 or something like that.
Yes, sir.
So now velocity at this point is this one. Velocity is another point is correct, this one. 1 degree difference is there. So I'll take ratio 274 upon 273. So how much it will come? Yes, something will come, right? Right? And then we take the difference. When we take difference, we will get the value. Yes.
Yes.
So it comes almost 0.06.
Kinetic supplement.
That means
Kinetic supplement. हाँ
get
खेलो.
it. So the rise in the temperature, the velocity also rises, right? Right, 61 centimeter per second. That is of
नाही. पण आज मध्ये काय प्रॉब्लेम आहे? तर आज रात्री.
Pratham, are you there in the class?
Yes sir.
Yes. Okay. Any more question from your side? Yes.
The last question, can you explain the intensity of
Density of what?
not not the density, sir, intensity of sound.
Okay. If anybody remember, I have explained it. Yes. In the resonance also I explain. Several places I explain. Yes. Anybody remembers? Yes or no?
So I know the meaning of the intensity of
So
sound, just wanted to know the formula and how
yes,
to apply.
formula it is directly proportional to square of amplitude, right? So
So your voice is cracking.
wait. Okay, I think it will be better. Right.
Still cracking.
Anyway, I have to change the mic only now. Lot of noises. So what I'm saying is the intensity is directly proportional to square of wavelength. Correct? Correct or no? I'll just explain it out. Who is more intense sound? One or two? Yes? Yes, tell me. One or two? Which one is more intense? So intensity is directly proportional to amplitude square, right? So whose amplitude is maximum? One or two? Yes? One or two? Hmm? I cannot hear. Any doubt? Yes? Which one is appearing maximum this amplitude?
First one.
First one, correct. Right now? Directly proportional to amplitude square. So there is a constant of intensity and we get the intensity at any point, or we can compare like this point 1 and this point 2 and this point 3. Where will be the maximum intensity?
Between 1 and 2.
No, at 1. Why? Here amplitude is maximum. So intensity will be maximum. Here amplitude is 0. So intensity will be 0. Here is somewhere in between, right? So it is 3, right? Maximum at 1, then 2. Are you getting? Because 2 is 0. नहीं समझा? समझा या नहीं बताओ? बड़ा बनाओ. हाँ?
Understand?
Okay. Any other question?
No, sir.
Okay. So in the sound, one more topic I'll take for you. Last topic for the day is what? Some activity, right? Do you like activity? So experience sound wave. What? Sound wave of different wavelength, of different
Yeah.
wavelength. Now question arises, how to find, sir, wavelength of different wavelength? Yes? Is there any way? Yes? Should I give example? Anybody have any example? Hmm? Okay. So experiment I'm saying, right? Right?
Right.
So in this case we can see, we'll take a glass of water and we'll just fill it, right? Right? Another will keep it totally vacant. Another will fill some portion it here. Another will fill some part here. Another will fill some part to some extent. Another we will take, again we'll fill something here. And we'll take one spoon, right? Right? So now within spoon we will apply the force here. What will happen? What will happen? The wave will be produced. Are the wave of the same length? Tell me.
No, sir.
So this is how you will experience a different wavelength. All of you will do. It is so simple experiment. All of you will do it.
Yeah.
I need a photo or video of this doing experiment. Okay. Where to send? Where to send? On my WhatsApp number. Okay. 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 So Vijay sir, Vijay sir,